Hello, this is Husam. This is a short demo of my final project. The course is titled Artificial in Pathology with a code of BE544 from the University of Louisville and Bioengineering Department. This application handles different tasks such as classification, augmentation, and segmentation. It is built using Python programming language. The web application is built using Flask package, and this application utilizes MySQL as the backend database. HTML, CSS, and JavaScript are utilized. Also, Bootstrap is used to enhance the interface. This application begins by asking the user to enter his credentials or register a new account. So let's create a new account. By pressing the register, it will create the account and redirect itself to the login web page. Let's log in. Each user has an individual or separate dashboard on tasks. The dashboard is divided into 4 parts. The first part is the data acquisition and entry, where the user can upload the different datasets or the whole slide images for pathology. For the second part, the user can apply live data augmentation. The third part, the user can apply data processing, so he can apply classification or segmentation. The last one is the interpretation and visualization part, where the user can investigate the history of the image classification and segmentation. Also, we can apply inference on the image classification and inference on the DZI or deep zoom image using segmentation. Let's begin by using datasets. It displays the different datasets that are uploaded on the dashboard. We can upload the dataset. So let's upload. The dataset must be compressed. To use it in the classification part, the inner folders must be categorized in different folders where each folder is a class or the category. It will start uploading, and after uploading, it will display the dataset in the table. To use it, we need to uncompress the dataset. So we can press on this option. If we need to delete this dataset, we can press on the trash icon. Let's uncompress it. The dataset is uncompressed. We can investigate the different folders of it. So we can open the uncompressed folder. It contains 2 folders, cats and dogs. For the cats, we can display any image or delete it. For example, this image and this image. This folder contains 200 files. So to load more images or files, we press on the load more option. It has loaded 20 entries, so we can go to the next page, display the last image. We can back and surf another for the dogs folder, an image and another image, like that. Let's return to the home. The uploaded dataset, which is called cats and dogs, can be used in the classification part. So we can enter to image classification. In image classification, we can define the different hyperparameters, such as the number of epochs and batch size. Let's select the scalar to be standardization, and let's change the title to be testing-std. We need to select the set. We have uploaded one and it appears here. We need to define the different categories to use. So in this dataset, there are 2 folders or 2 categories. They are cats and dogs. We can press on proceed to start the classification task. The website is built on threading, so it doesn't block the surfing process. So we can apply another tasks. For example, let's repeat the classification on another classifier for another scalar, for example L1 normalization, rename it to testing L1 and proceed. So we have applied 2 classification tasks. To get the history, we need to return to the home and click on image classification history. The third column in the table indicates if this task is completed or failed. If complete, we can investigate the different options such as history and evaluation. If this task failed, it will display the reason of failure. So for the standardization part, we can display the initial configuration. They are the configuration we entered as hyperparameter during the classification procedure, and the post configuration are the final configuration. It includes also the different shapes of the training, validation, and testing subsets. We can display the history. It shows the training and the validation metrics for the different epochs. We can notice here that there are only 9 epochs. This is because we have an early stopping with 5 epochs. If we check the second one, we can notice that it's only 10 epochs, and if we remember the indicated, each one of them should run for 25 epochs. We can plot also the history. It shows a different metric. We can open a new tab and save it if we need. We can also display the different evaluation for the training, testing, validation. We can also delete any of them using the trash icon. To continue with the classification pipeline, we can end with the image classification inference. We select classification run. We had run 2 classifiers, one using standard deviation and one using L1 normalization with the same hyperparameters. We can select an image and apply. It should display the results. The result consists of two parts, the category and the probability to gain this category. Let's try the L1. It shows a low probability, but it classifies the image correctly. Let's select another image. It classifies the image wrongly. Let's test another one. For the standard deviation, it predicts the image correctly. We can also work on the pathology slides using the whole slide image handler. Here we can upload the whole slide image on the format of SVS. So let's select a whole slide image. It's being uploaded on the server. The SVS is uploaded successfully. To handle the SVS and to present it on the web interface, we need to convert it to DZI format or the deep zoom image format. We can press on this button to start the generation. We can define the tile size, width or height, and the overlapping. We can define the overlap with 1 and rename the title as we wish. Let's start conversion using this button. It notifies us that the process can take long time to complete based on the size and the number of pixels in the image. It's also built using threading, so we can apply another task or surf the website during the conversion process. Once the whole slide image is converted to the DZI format, we can surf the deep zoom image handler. If we open that, we will notice that the process hasn't completed yet, so we can work on another part of the project until conversion completes. Let's test the data processing using live image augmentation. Here we can upload an image, for example a cat, and apply different configurations such as rotation, zoom, and shearing. So if we selected the zoom to be 90, there is an option that's called specific or random. Specific means we need to convert the image with 90 degrees exactly. If we selected random, it will select a value between -90 and 90. So let's try first specific and press apply. It rotated the image 90 degrees. If we selected random, it will rotate the image with a random value. This random value is displayed in the notes here, as the selected value is 56, and by trying another one, it's 40. Let's change the brightness also. The rotation is -53 and the brightness is 31. So let's set the brightness to 94. Let's disable all options and test the hue. Let's set it to 90 and apply. It changes the hue of the image. If we need to apply two of them, for example, the rotation, the hue, if we pressed apply, it will select only one of them. This is because we have another option here, which is called single or multiple. For single, it will select one of the activated options randomly. If we selected multiple, it applies both of them cascadely. So if we run, it will rotate the image by 35 and it changes the hue 12. The DZI is converted successfully. We have two options to open it and to delete. We can open it. It shows the DZI and it loads. If we hover on any of the tiles, it draws a green rectangle on the image. We can zoom a specific portion. We can apply also different options such as rotation to the right or to the left, zoom out and zoom in. We can toggle the full page, display it as a full screen. We can also apply different tasks, selected tile. For example, we can open the notes to know the different options. For example, if we press on the space, we can open the tile externally. For example, if we hover on the tile and press on the space, it will open the tile. We can save it if we need. We can also apply digital image processing by hovering on the tile and pressing on Q. For example, this part and press Q. For this part, we can apply thresholding. So we can set 153 with a blurring of 1 and apply visually, and the process tile looks like that. We can increase threshold like that. We can also it. We can also apply live segmentation on a specific tile by selecting first the segmentation run by pressing on V. In this case, we didn't run any segmentation, so we can return to the home and open the segmentation. We can select the SVS file. The segmentation is based on weekly supervised segment unit. This requires the annotation of the SVS file using QBAS. So from this file, we can use QBAS and make a set of annotations. This annotation must be named in QBAS and provide a different annotation so we can use it in the extraction process. So for example, if the QBAS project contains 10 annotations, we can only specify 2 of them to use. Let's upload the project and set the title. Currently, there is a specific model which is called manual unit. It works on an image with a size of 256 256 by 256 by 3. We can apply any scalar. Let's set the number of epochs to 10. We can also change a hyperparameter. After setting them, we can proceed the conversion implementation process. To get the history, we can open the segmentation history. Currently, there are no records in this table as the segmentation process is running on the server. We can check the status of the segmentation history in any time by pressing on the refresh. If there are any completed runs, they will be displayed here. So the task is completed and we can display similar to the classification. We can display the different options such as history and evaluation. They are the initial configurations, the post configurations after the running. The history displays the same metric of the classification but with two additional metrics. They are the dice score and intersection over union. We can display also the history plot and open it in a new tab and save it. We can display the evaluations, so the training, validation, and testing accuracies are above 96, and the dice coefficient are above 95, the IOU coefficient are above 74, and so on. After creating a successful or a completed segmentation run, we can return to the DZI handler. We can display the image. By pressing again on V, we can select the segmentation run and apply the segmentation run. We can go to any of the tiles and press G. After selecting the segmentation, it will send the tile to the server and start sending it. It will overlap the tile with a new segmented one. You can move to the left and apply segmentation on this tile. It will be like that, and apply on this tile like that, and so on. So in this project, we have displayed different options such as live data augmentation, a specific image, segmentation using different deep learning classifiers such as VGG and MileNet, and finally we could handle a pathology slide in the SVS form to be converted on the DZI format to be displayed on the web interface. We could also apply segmentation on the SVS file using the annotation made previously using QBAS application.